You're listening to the Pool Envy Podcast. Code, compliance, craftsmanship. Hosted by Jason Davies. Let's dive in.
Every time someone tells me their pool tingles when they go swimming, I know what's coming next. They'll say, we replaced the pump, grounded the light, checked the breaker. Everything still tingles. And that's when I know nobody ever bonded the pool correctly. Today we're talking about one thing that separates licensed work from backyard guesswork: equipotential bonding. This isn't optional. It's not a suggestion. It's the invisible network that keeps you alive around water and electricity. I'm Jason Davies, licensed pool, electrical, and HVAC contractor, and this is the Pool Envy Podcast. We cut through the noise and talk about what actually makes pools safe, legal, and built to last. If you're a builder, inspector, or homeowner who actually cares about doing it right, this episode, 100% definitely, it's for you. Bonding is the great equalizer. It ties every conductive part of the pool, the rebar, the ladders, the handrails, light niches, the deck steel, and even the pump motor, so they all share the same electrical potential. That way, when you step barefoot from the deck into the water, there's no voltage difference trying to move through you. People confuse bonding with grounding. Grounding sends fault current back to the source. Bonding makes sure that current never has a reason to start. It's not prevention, not reaction. If bonding is done right, you could unplug every piece of equipment in your yard and still be safe touching the metal rail and wet concrete. If it's done wrong, even a few stray volts from the utility side can turn your pool into a live circuit. NEC 680.26, my favorite chapter, spells it out clearly. An equipotential bonding grid shall be installed to reduce voltage gradients in the pool area. Not optional. Not if convenient. Your bond must be connected to the reinforcing steel of the pool shell, the perimeter surface within 3 feet of the inside wall of the pool. All fixed metal parts within 5 feet horizontally of the water. And all electrical components tied to the pool: pumps, heaters, lights, junction boxes, transformers, UV sanitizers, and anything else metallic. Concrete pools usually get 4 uniformly spaced connections around the pool. Fiberglass pools or vinyl pools use a number 8 solid bare copper ring that encircles the pool, tied into anchors and fittings. And every connection used must be listed corrosion-resistant direct burial, brass, copper, or stainless. Cannot use pot metal, cannot use galvanized, and absolutely no big box store split bolts jammed into wet concrete. Because if you do, we will find it. Here's where things usually fall apart. The builder subs the steel crew. The steel crew never sees the bonding plan. The electrician shows up after the shotcrete guys and says, I'll just clamp the pump and call it good. Then the deck guys cut through the bonding ring setting pavers. Or somebody replaces a rail anchor with plastic because they didn't have the right bronze cup. Eventually, each moves and breaks continuity. And the continuity, that's the whole game here. You can't eyeball bonding. You can't say, oh, it's fine, there's copper somewhere. Either it's connected or it's not. And when it's not, you get the classic tingle on the pool ladder. That's not a little static. That's a voltage difference. And now your body is the bridge, perhaps over troubled water. When a pool isn't bonded, it becomes a cluster of floating electrical islands, utility neutral drifts, a transformer leak, even irrigation nearby. Each one can take a component and float it to a different potential. The moment you grab a metal rail, that difference equalizes through you. Hey, you're an anchor for something, right? People die from it, though. Not from a short circuit, from a few volts that never had a safe path to equalize. Equipotential bonding eliminates that path. Every conductive point shares the same potential. No difference, no current, no shock, simple, elegant, invisible. If you're serious about electrical safety, you will test bonding with a low resistance ohm meter, Measure from the pump to a ladder, from the ladder to a light niche, from the light niche to a deck anchor. You should read continuity within about 1 ohm. If you get 3, 5, or infinity, you've definitely got a break. On new builds, your inspector should. More importantly, though, your contractor has a responsibility to do this as well. Physically, look with your own eyes. The number 8 copper wire should be tied to the steel and the bonding ring tied to the anchors. After that, testing and documentation are your only proof. Once it's hidden in concrete, it's hard to see. Homeowners, this isn't DIY. You cannot see bonding, you can only measure it. I've inspected commercial pools with beautiful automation systems, ozone, UV, heaters worth 10 grand, and not one continuous bond. The pool passed every other checkbox on paper, but electrically it was Russian roulette. Bonding failures don't announce themselves. They just wait until someone feels a zap that shouldn't exist in a safe system. Or better yet, until a caring pool contractor sees it. Here's the truth. Bonding isn't about electricity. It's about respect. Respect for physics, for code, and for human life. If you're a professional, do this correctly. If you're a homeowner, demand proof that it was done right. And if you're not sure, schedule a safety and systems evaluation. We'll verify it, document it, and show you exactly what's connected and what's not. Visit us at poolenvy.us. This is the Pool Envy Podcast. I'm Jason Davies, licensed in Florida, CPC 1460695, and Wisconsin 1543940, along with Texas, TICL 1350. Stay safe around water and electricity, and I'll see you next Tuesday.
Thanks for listening to the Pool Envy Podcast, where licensed pool professionals speak up. Hosted by Jason Davies, licensed across Wisconsin, Florida, and Texas. For more insights, subscribe and join us next time.